All right. Thanks, Scott. So as you said, I'm from the Illinois RiverWatch network. So this is, and did my slide change for you guys? Because sometimes I have issues with that.
Yeah, we're seeing education, science, and stewardship.
Okay, cool. Just wanted to check. Okay. So the Illinois RiverWatch network is a statewide community science program that trains volunteers to collect water quality data in their local streams. And RiverWatch has three main goals. And they are to educate community members about the importance of water quality, to collect good, high quality data, and then to also provide opportunities and information for everyone to become involved with stewardship of their local streams. And so a little bit of background on RiverWatch. It was originally formed in 1995 as part of the EcoWatch network, which was housed by the IDNR. And the EcoWatch network had a bunch of different programs included in it. So that was RiverWatch, Prairie Watch, Forest Watch, and maybe a Wetland Watch. But in 2004, EcoWatch network lost their funding and was cut. And in 2006, National Great Rivers Research and Education Center picked up the RiverWatch program. And the RiverWatch program is the only one of those EcoWatch network programs that is still going on today. And we are still based out of NGREC. So this is a picture of our building. We are located in East Alton, so just near St. Louis on the other side of the river. So we are based out of Illinois, on the Illinois side of the river. And our program is important for a few reasons. Of course, the governmental agencies like the IDNR and IEPA are collecting stream quality data, but they can't get out to all of the streams every single year. So our program helps provide supplemental data to determine stream health on a statewide level. And then we also collect trend data. So we're collecting data at the same time of year in the same places every year, which helps us get an idea of how these ecosystems are changing. And we only monitor smaller streams, so streams that can be waded into, but everything that happens in those smaller streams affects our larger rivers. And then our community scientists are like surveillance cameras of the streams. So sometimes our community scientists are the first ones to even notice that a problem is going on in a stream. So today I'm going to be talking about three of our monitoring programs. Our macroinvertebrate program and our winter chloride program and our freshwater mussel monitoring. So starting with our macroinvertebrate monitoring, this is our longest running program, and this is mostly what we're known for. So if somebody says RiverWatch monitoring, this is the program that they would be talking about. And if you go onto our website, it's just called RiverWatch monitoring. But it is looking at macroinvertebrates, and I will talk about what those are in a few slides. And for this program, our volunteers attend a training workshop. So they're all officially trained volunteers, at least one at each site. They're allowed to bring other people with them who are untrained. And at this training session, it is a full day where we give them an overview of the program, and we teach them to identify over 30 macroinvertebrates. And then we also teach them the field methods. So there's a outdoor field component to the training, and these training workshops are held in March through May. And after they are trained, they go out and collect data. In May and June is the main time frame for the program. And the data collection involves doing a habitat survey, so measuring things like the depth and width and velocity of the stream sediment, the vegetation, and things like that. And then they also do a biological survey where they collect macroinvertebrates. And they do this using a deframed kick net, and they disturb the sediment, and all the bugs will move into the net. And then after they do this, they identify those macroinvertebrates, usually at one of our open labs. So we can help them with the with the identification, and then they send the samples into us. And so I've been talking about the macroinvertebrates, but if you are unsure what that means, macro means that they're big enough to see with the naked eye, and then invertebrate obviously is without a backbone. So this includes things like crustaceans. So there's a picture of a scud here. Worms, so there's a flatworm, mollusks, so you can see the snails in that picture. But most of the time when we're talking about macroinvertebrates, it's talking about insects. So there's a picture of a larval damselfly in the bottom right corner. So why do we use these macroinvertebrates? And they are really important for the environment. They are a big part of the food chain. So they break down organic matter, but they also serve as a food source for other organisms, such as fish and frogs. And their diversity is important for the freshwater ecosystem, just like the diversity of anything is important for an ecosystem. And they are impacted by pollution and habitat changes, whether that is natural or from humans. And a lot of these guys live in the water for multiple years. So when we start seeing changes in their populations, we know that there is some bigger thing going on that is happening to cause these changes. So once our volunteers collect the macroinvertebrates and identify them, they can use them as bioindicators to get an idea of the stream health. So some of these macroinvertebrates are really good at living in pollution, and some of them are more sensitive to it. So based on what we can find, we can get an idea of how healthy a stream is. So once our volunteers collect this data and send it in to us, what happens to that data? So everybody submits the data to us, and it is available on our website, but not in the easiest to manage form. It's basically, I should have put a picture in the presentation, but it's basically a map of all of our sites that you can go look at, and it is available that way. But then if you are interested in the data in your area, you can always just email us and request the data and we can send it to you. We always encourage our volunteers to communicate their findings with landowners of their site. That helps build the relationship with landowners, because that's usually our biggest obstacle with getting volunteers out to sites, is finding and having those relationships with landowners. But then landowners are also the ones that can help get involved and actually make a difference in their streams. And then we encourage our volunteers to present in meetings and things like this, like Patrick is going to be doing today. And then we also encourage our volunteers to get involved with watershed groups. And so most of the time, our data does end up getting used for watershed groups and city planning and forest preserve districts. Those are the people who are most often using our data for restoration plans. Okay, so that was just a quick overview of our macroinvertebrate program, because I know Patrick is going to be talking about how DeKalb County is using it. So I didn't want to go into any of the data since he'll be, I assume, talking about his. So this program that I'm going to be talking about now, and Scott mentioned the issues with chloride, is our winter chloride watchers. So this program started in 2021. So this is, we just finished our second season of this program. So this is really focusing on how road salt is impacting our streams. So road salt is used in the winter to melt snow and ice after storms or during storms. And most often road salt is sodium chloride. So that's the same stuff that we use in table salt, but other road salts can include magnesium chloride, calcium chloride, and potassium chloride. And you'll notice that all of those have the word chloride in them. So a lot of times road salt and chloride are used interchangeably. And every year in the US, over 20 million tons of road salt is used. And so why do we need to study it? Chloride damages transportation infrastructure. So about $5 billion per year in damage to roads, bridges, and cars. And then it could be potentially threatening our drinking water quality. So this hasn't really happened in Illinois as far as we know. so far, but some communities in New York State are finding salt in their drinking water that is at levels that are unsafe for individuals who are supposed to be on a medically subscribed low salt diet. And then finally, chloride dissolves into the runoff and travels into our rivers and stream where it is toxic to our aquatic life. And then I can put these links in the chat after the presentation, but I am going to go to a couple of websites. So first is a story map that we have of our Winter Chloride Watchers program. And this gives a lot of background on the program that you guys can read about if you're interested. And then also summarizes our data from the first season. And we are currently working on a summary of the data from the season that just ended. So on this story map, it gives you more background on salt. And then my favorite part of the story map is that Danielle actually put together pictures that volunteers sent in of their sites during the summer and then during the winter. And I love these little slidey things. I think they're so cool. So for our chloride program, it is a lot easier to get involved with. So for this program, it's only an hour-long virtual presentation that you have to attend for the training. And we do these trainings usually starting, we don't have any officially set up yet, but they usually start in September-ish time, September, October. So you just have to attend that 1 hour training presentation, and then you register your site. We send you equipment, and then you can get going and do the monitoring. So for this program, the monitoring involves just getting small samples of water, and then you get these Quantab chloride strips to do your monitoring with. So it only takes about 15 minutes to do the monitoring, but for this program, we have you go out multiple times throughout the season. At a very minimum, we go, Danielle, you can correct me in the chat if I'm wrong, but I believe the season runs from October to May. So at the very minimum, we would want once a month, which would be 6 times. But a lot of people do more than that, maybe every other week, or they plan and go before a storm and after a storm. So we let the volunteers choose how often they're going out to do the monitoring for this program. And then after people have their data, for this program, we use a online database called Water Rangers to store the data. And I'm going to go to that in a second so you can look at how the data is presented. So you can just submit your data online for this one. And then I'm not going to go through our results from the first year, but they are summarized here on this story map that I'll put a link to in the chat if anybody is interested in reading the summary from our first year, so 2021 to 2022. And then there's more of those fun slidey photos at the bottom. So then the data platform that we use is called Water Rangers. So to find us on Water Rangers, the homepage, well, this is the data platform. So you would go to the data platform, and this is kind of what it would bring you to. And then you would want to go to groups. And then if you type in winter, we're one of the only 2 winter named groups, so Winter Chloride Watchers. And so then you get brought to, I think it's still loading. Okay, this map of all of our sites. And you can see there's a lot going on in the St. Louis area because before we brought the program here, Danielle and a group from the St. Louis area has been doing chloride monitoring for the last 10 years. So their data is on this map as well. But this is what we got going on, you know, on the Illinois side since we've started this program 2 years ago. You'll see we're missing a big gap of data right here. So if anybody is interested in joining the program, we would appreciate filling in some of these gaps up in Northern Illinois. We got a lot of people monitoring in Chicago. So on the data map, you can explore what's going on at these different sites. And then if you click on one, you can view a summary. And it'll give you something that looks like this, reporting what the data looked like for this site. So you can see this one was monitored from November 2021 to May 2022. And you can see all of these peaks would probably be after snowstorms, and then it kind of goes back down. Our highest point was 277 chloride, which in Illinois, the toxic to aquatic life minimum is 500. So this is staying under that, but still higher level of chloride than we would like to see. And then you can see it doesn't really, our base was 147. It doesn't quite get back down to there until April. So you can play around with that data if anybody is interested, and I'll also put a link, the link that's on the presentation in the chat after I'm done. Okay, and then the final program that I'm going to be talking about is our freshwater mussel monitoring program. And this program is very similar to the first program that I'm going to talk about. Just instead of doing macroinvertebrates, you do mussel monitoring. And this program is not as widespread as our macroinvertebrate program, just because it's a little bit more, I don't want to say intense. It's more things that have to go on, working with endangered species and things like that. So this one is more focused on groups who are ready to participate and continue, instead of just asking like individuals to come into the workshops like we do for our other one. So this would be something that a group requests from us to help them get set up to monitor mussels. And because this program is so similar to our macroinvertebrate program, I'm not going to cover very much on it. And I'm going to instead highlight one of the projects that we have going on that started from this program. So just a little bit of background on freshwater mussels. North America is a hotspot of biodiversity for freshwater mussels, but their populations are all declining, both in size and in diversity. And a lot of this comes from the button industry. So when that was going on, a lot of button factories were just taking up thousands and thousands of mussels to punch buttons out of their shells. But even after that has ended, our populations are still decreasing. And part of the reason is because of the pollution and sedimentation that is going into streams, because mussels are filter feeders. They're really sensitive to those things. And then also invasive species have become an issue for them. So the Asian clam and the zebra mussel are both just better at reproducing and better at filter feeding than our freshwater mussels. But also the zebra mussels will basically glue themselves onto any substrate that they can find. And so that can include freshwater mussels, and they'll glue them shut. So both of those invasive species have also become an issue for them. And so the project that I'm going to be talking about is occurring in the Sangamon River, which is the upper Sangamon River, which is in the Champaign area. And so here's all the partners and our funding for this project. And this is a long-term multi-year tagging project that we've been working on. And so for this project, there's a few questions that we're trying to answer. So we're trying to see in the upper Sangamon River how many mussels there are and what species are there. We're trying to look at how do the mussels move in the river. We're looking at what stressors are affecting the mussels. We have a genetic study going on to look at the genetic changes along the river. And then we're also doing a morphometric study. So that is looking at the size, shape, and growth rate among the mussels. So these are the sites that we are monitoring at. So you can see we're just west of Champaign on the Sangamon River. And for this project, it is all volunteer run. So we are obviously there and we have some scientists there to help, but all of this data that we're collecting is through the help of volunteers. So when we get there, we set up, we have 10 transects, and then an upstream and a downstream area that we are searching for mussels in. We do on-site training. So this is one of the scientists that we're working with, Sarah Douglas from the INHS. So she does a lot of the training and a lot of teaching people how to identify the mussels in the morning. And then the volunteers all go out and start digging around to collect the mussels. And then once we have the mussels, we are tagging them on both shells with a vinyl tag. And then we are identifying and then taking their measurements. So their width and depth and their weight. And then the morphometric study that I talked about, looking at the size and shape, we are also taking photos of all the mussels that are tagged. And then our genetics study, Sarah has been running, well, she's been taking the samples, and then we've been running them at a lab at Missouri Botanical Garden. So we are taking genetics from 2 species, and then after that, all the mussels get returned to the same transects that they were found at. And then we just have some habitat measurements that we're also looking at for this study. So then just a quick summary of what we've found so far. These are some of the common mussels that we have found, and this is like our top 10, but common is maybe not the right word for some of them, because we range from 475 with the pimpleback and 29 with the deer toe, but these are the top 10 of what we have found so far. And then this is also an example of what our morphometric pictures look like for these mussels. And so for the first 2 years, we started this in 2020, and we only do four sites a year. So we've only monitored all the sites once so far. For our first 2 years, we collected 2,796 mussels, and of those we tagged 1,400 of them, and we have found a total of 19 species. And I think I'm kind of pulling this number out of off the top of my head, so it might not be correct. But I believe in the Sangamon, historically, there have been over 30 mussel species found, maybe even over 40. So definitely a decline there. And then we had a few differences in our upstream and downstream site. So on the left here, these are all mussels that we only found on our most upstream site. So that would be upstream of any cities, which the biggest city that is next to the Sangamon is Mahomet. So not like a super big city, but so these 3, the spike, fat mucket, and monkey face, were all found at our upstream site. And the spike is the only endangered mussel that we found during the study. And then at our bottom 3 downstream sites, we found pink paper shell and maple leaf, which was not found at any of the upstream sites. And so for this study, we are currently working on our genetic and morphometric analyses. And then we're also working on a report comparing the historical data, but we still have 8 more years of the study. So we haven't gone back to any of the sites yet. So we haven't started the recapture part, which we will be doing this year. And I know it's a bit of a drive for McHenry County, but this is open to volunteers. So if anybody is interested in making a day trip to the Champaign area to attend one of these, the dates are listed there and can be found on our partner's website. The Upper Sangamon River Conservancy is the one who is collecting the information of who's attending. And then finally, we do have a video about this project that won Best Documentary at the United Nations Water Film Festival this year. So it's about 7 minutes, and I recommend that everybody watches it. So that's the end. I don't know if we want to do questions for mine now or have Patrick go and then do all the questions at the end.
Well, I would like to at least make a comment. Thank you so much for your presentation, Hannah. But I want to make sure everybody understands in regard to the chloride program. a lot of us on this meeting are part of MS4s. I know, I don't think Kirkland is large enough to have an MS4. As I recall, I tried looking that up, but a big focus of the IEPA's MS4 program is chloride reduction. You know, for people who aren't familiar, the MS4 it refers to it's a National Pollutant Discharge Elimination permit, and it stands for Municipal Separate Storm Sewer System. Seems like there should be another S there, I'm forgetting. But this is a permit that municipalities and counties have to maintain. A big part of it is education and outreach, and then also training for staff. So participation in the chloride program with Hannah would be eligible for meeting certain requirements of your MS4 program. So just keep that in mind, that a lot of these things can have multiple benefits in addition to increasing your own understanding and participation. So in any case, that's all I had.
Scott, I'd like to just remind everybody or tell everybody that about 10 years ago, the Kishwaukee River Ecosystem Partnership sponsored a mussel workshop, and it included a day-long effort to sample sites in the lower Kishwaukee and Killbuck Creek watershed. And we compiled a pretty extensive database of kind of a baseline sampling of mussels at that time. And I know all that data has been registered with the Natural History Survey. If there ever was an interest in doing something up here, that might be a good place to start. I mean, we found a lot of rare species in that inventory.
Well, and you know, as far as data collection, you know, it's individual data collections are interesting, but it's really seeing changes over time that really starts to yield relevant data. So you're absolutely right, Jerry. If you've got a site, and this is true with chlorides too, but if you've got a site that you've got data, you know, that is actually a really good starting point for additional collections. Just to clarify, Hannah, you know, a bunch of us are from McHenry County, but we have representation from Boone, Winnebago, and DeKalb County on here as well. So any other questions or comments for Hannah? If we have time after Patrick's presentation, we can certainly do additional questions. But if there are no additional questions for Hannah, we'll go ahead and ask Patrick to get his presentation lined up. And if anybody hasn't put their name and who they represent in the chat, please do so. It really helps out with when I'm doing the minutes.
Okay, can everybody hear me?
Yep, I can hear you and see. It looks like your first slide with your name at the top right.
Okay, perfect. So I introduced myself earlier, but I'll introduce myself again. I'm Patrick McCrea. I work with the DeKalb County Forest Preserve, natural resource manager, but also the wildlife ecologist there. So I've worked in restoration since about 2009, and I've always had an interest in local flora and fauna. And as a kid, I grew up playing on creeks, and so I'm drawn towards these aquatic systems. And even on our vacations, we spend a lot of stream or near some body of water. So at the DeKalb County Forest Preserve, I'm still working on restoring native areas, but then we also get to look at the wildlife that exists within DeKalb County. So the mission of DeKalb County Forest Preserve District is to acquire lands in order to preserve, protect, restore, and restock the flora and the fauna and the natural beauties of such lands in their natural state and condition for the education and recreation of our citizens. And so that's pretty complex. Like, how do we preserve, protect, and restore what took thousands of years of evolution to create? And so often our goal is to understand the ecosystem and determine if that ecosystem is healthy. So where do we start? Well, we start looking at what species recently existed on the landscape, and we look at what species exist now. We try to determine if we have a functioning ecosystem that can support them. And from there, we kind of make the best management decisions on how to preserve, protect, and restore those populations. So today we're going to be focusing on stream ecosystems. And how do we understand if our streams are healthy? And one of the ways is to focus on biological indicators. So the definition of biological indicator is an organism or group of organisms that's used to assess the health of an ecosystem. And so here you can see a freshwater mussel. This is a plain pocketbook, a stone cat, fish down below, and then a stone fly larva. So are our stream ecosystems functioning? So what we're going to look at is what information already exists, what opportunities do we have to build on that information, and then we'll try to fill in some of the gaps with our own research. So with what information already exists, we can look to the Illinois DNR. They've done fish surveys every 4 years to help us understand the health of the streams, and they plug in the data they get from those fish surveys into an index of biotic integrity, and that gives them a read of health. And then we've also got the Illinois Natural History Survey, which has a lot of past records, but then they also have a lot of ongoing studies. So we're always happy to work with either of these groups. And the one study that we're lucky enough to work with right now that's going on in the Kishwaukee watershed is one that's involving the non-native corbicula. That's a non-native clam. And so they're looking to see if that clam has any effect on our native freshwater mussel populations. So then what programs can offer us insights into stream health? And RiverWatch has really been one of those great programs that allows for citizen participation. We were able to get citizens out there, and we're also able to gain a better understanding of how the stream ecosystem functions and overall health of that system. So what I'm going to do now is just kind of show you what you might experience doing RiverWatch, because you experience a lot more than just the invertebrates. For one, you experience the landscape. On one of our surveys, we walked out and there was this small little soft shell turtle, or spiny soft shell turtle. And you can see how small it is compared to that truckee. And these turtles, they breed in May and June, or sorry, they lay their eggs in May and June, late May, early June, on gravel bars along the south branch of the Kishwaukee. And so they're hopefully going to have stable stream conditions. Then from June till August when those eggs hatch. You probably come across some of these fingernail clams. These are some of the smallest filter feeders that you see in the streams. You might pick up a rock and see fish eggs. And if you look close at this photo, you can see the little eyes of the fish fry developing in there. So if you do pick up a rock like this, then you want to carefully place it back in the water, but it's something that's pretty amazing to see. You can come across turtles. Northern map turtle was a new record for DeKalb County about 3 years ago, I think. And the distribution for this turtle seems to be changing. If you're in a wetland near your site, or you're in the backwaters, sometimes you come across American toads. You can see these long strands of toad eggs. I think just kind of a beautiful picture. You often come across, well, not often, but you sometimes come across these amazing snapping turtles. They're just beautiful. You sometimes come across some of the darter species. So we see rainbow darters in the Kishwaukee River watershed. And these guys, all the darter species don't have a swim bladder, so they are usually sitting on the bottom, and you can see those guys sitting on their pectoral fins. You might come across mayflies emerging. You might come across, this is a red-winged blackbird feeding on some mayflies. Along the banks, this is water stargrass. This is a species that's usually submerged, but then as the banks recede, this one flowers on the bank. So you might see some of these wildflowers. We thought this was cool. This was a fishing spider that we saw, and it had all its babies on its back. You could come across, this is another darter. This is a fantail darter. And this species digs a nest under a rock, and then the female lays the eggs on the underside of that rock. And I've read a few places that some think that bulblets, like those little bulbs on top of its dorsal fin, look like fish eggs. So there's a theory that the male who makes the nest, the female comes in the nest, sees what she thinks is eggs, thinks, oh, you're a responsible father. So then she also lays her eggs in that nest. And then the male is the one that cares for those eggs. Some mornings you walk out and there's pretty heavy dew, and usually the damselflies and the dragonflies, they wait till all the dew dries off of their wings before they fly. So we walked out one morning and came across all these American ruby spots along the stream in this box elder tree. And so if you're looking in the water, sometimes you see things like this. And this is a caddisfly net. So this is the one that the net building caddisfly built. And so as the water flows, organic matter goes into the net. And then that caddisfly will come out and gather organic matter off of that net to feed. And so I've circled here the net building caddisfly. You can also see a couple other caddisflies in there, one of the case makers, a snail in there, and a riffle beetle. So that's before you've even gotten to the lab. And so when you get into the lab, you kind of get to see some of those invertebrates up close. And this is Carl Von End. He's been helping us with a lot of the RiverWatch research too. He's been a great volunteer. And he's also a retired NIU professor, so he knows a lot about aquatic invertebrates as well. So this is the aquatic sow bug. This is a damselfly, and those paddles on the back, that's where that damselfly is taking in oxygen. You come across stoneflies and mayflies, and stoneflies have 2 tails, mayflies have those 3 tails. You might come across bloodworm, and you can see that in that picture on the left, and it's with a mayfly. And then you might come across creatures that you don't know. And that's why it's really great to work with people like Hannah and Danielle, because they can help you identify some of these other creatures. This is another picture of a mayfly. And this one just kind of highlights those feathery gills on the side of its body. And those are where it's taking its oxygen. So with the help of volunteers, we've been able to monitor 9 sites within the preserves for the past 3 years. And this year, volunteers decided to start monitoring a 10th site. And so it's been great to start building on long-term data. And there was some data that existed previously. And that's awesome to have volunteers that are interested in participating. So we always love that the data is managed outside the agency, and then all the data also contributes to a larger data set. So then we've also been working independently to better understand our stream ecosystems. And that focus has been largely on freshwater mussels and diversity and distribution within the county. So in our search to better understand freshwater mussels, we've been fortunate enough to work with shed aquarium biologists and INHS, who have all helped improve our knowledge of freshwater mussels. In 2017, Al Roloff, who was a former natural resource manager for DeKalb County, he introduced me to freshwater mussels. And before that, I really had no idea about the diversity of freshwater mussels. And he was working with Carl Von End and then Roger Kolsluck. And all these guys, I just got to thank them, because they do such a great job of keeping you motivated. And also they really help you build on your knowledge. So I just want to say thanks to those guys. So why did we focus on freshwater mussels? Well, U.S. Fish had determined freshwater mussels to be one of the most imperiled groups of animals in North America. Chicago Wilderness and Open Lands was calling for ellipse conservation, and ellipse is one of the species of freshwater mussels. Illinois Wildlife Action Plan also had ellipse listed as a species in greatest need of conservation. At the start of the surveys, black sandshell and slipper shells were species listed on Illinois Threatened and Endangered Species list. And then we also knew they were a good biological indicator. So we set out to set up, basically get baseline data. So our initial mussel surveys focused on understanding the diversity and distribution. And between 2017 and 2020, we surveyed 25 sites, 15 sites within the Kishwaukee River watershed and 10 sites within the Fox River watershed. We surveyed sites on both public and private land, thanks to helpful landowners. And that really did make a difference because the Forest Preserve doesn't represent all the places throughout the county. So what we found was 22 live species of native freshwater mussels within the county. And so that list to the right is all the species that we found. One species, the spike, we found only relic shells. This species may be extirpated from DeKalb County. We also found recently dead pink paper shells. So there's possibilities to definitely find more species, but that was what we had found throughout our surveys. So I want to give you an example of freshwater mussels because they're really kind of neat animals. And so this is a picture of a smaller stream. This one's down in the Fox River watershed, but this is Little Rock Creek by Afton Forest Preserve. And so freshwater mussels, like any other animal group, prefer different habitats. So some live in smaller streams, some live in larger streams, and then within those streams, some prefer riffles, some prefer pools, and some prefer runs. So this is a giant white heel splitter that we found at that small stream. And so this is Damon. He's been a great help with the DeKalb County Forest Preserve and has always helped to build on our knowledge of the ecosystems. And so the one he's holding is likely well over 15 years old. And then there's a smaller one in the photo to the right. This is a slipper shell. So this one was listed as threatened species in Illinois. And now it is delisted at this point. But this is a small mussel. This is its adult size. And that's in those smaller headwater streams. Ellipse, we found ellipse in that smaller stream. And we found cylindrical paper shells. Cylindrical paper shells are kind of faster growing mussels. So they've got a thinner shell, but then they grow a lot faster than some of the other species. So then you get into some of the larger river systems. And so this is the south branch of the Kishwaukee River by Russell Woods. This is a fawn's foot. You can see those chevrons on its shell. And this one, again, this is a smaller species. It reaches adult size. This is adult size here. Here's a pimpleback. You can see the pustules or the little bumps on the shell. And this one also, you can see those rings. And so you can kind of gain an idea of the age of freshwater mussels by counting those rings. Much like a tree, in the wintertime, they're growing a little bit slower. So I've counted this one a couple of times and I come up with somewhere around 13 years old. And I'm always amazed at the age of how old these individuals can be and how small they are. This is a Wabash pigtail. These are some elk toe that we tagged while we were doing work with the Shed Aquarium. These are muckets. Muckets are probably the most prevalent freshwater mussel that you'll see in the south branch of the Kishwaukee River. And they do vary in color sometimes. Sometimes you get a deeper red than others. Three ridge, these guys have these three ridges that run across their shell. And plain pocketbook, which are far from plain. I think these are just beautiful with these green rays. So mussels are filter feeders. People refer to them as the liver of the river. They're constantly pulling out organic matter and bacteria. even in death, their shells will be used by fish. This is a log perch, which is alive. He just looks unhappy because he's out of the water. But we picked up this shell, and this log perch was finding refuge in there. And then also sometimes their shells are used for fish nurseries. This one's full of fish eggs. And this one is just a size comparison, so you can see what an adult mucket looks like, or the adult mucket is probably around well over 15 years old. And then the smaller one, it's probably 1 to 2 years old. And you can see a byssal thread hanging out of that smaller mucket. And when they're small, they have this thread so it can help them anchor into the river. So one of the wild things with freshwater mussels is their life cycle, and that's also what makes them more vulnerable. They have a complex life cycle, which they rely on a fish host in order to reproduce. So the male releases in the stream, the female becomes pregnant or gravid with these little babies called glochidia. And then those glochidia have to attach to a fish. They live part of their life on a fish. They mature and then they drop off. And that kind of helps with redistribution too, because these mussels aren't moving that much once they're adults. So here's the video. So once you become gravid, you have to attract the fish. So a lot of them try to attract the fish in a different way. And so this was one video that we took. This is in Indian Creek in DeKalb County. And this is a plain pocketbook, and you can see this lure that she has. It looks very similar to a fish. You can see the eye spot, you can see a lateral line, and you can see what looks like fins. And so she's going to wave this lure in the stream, and she's going to hope that a fish comes by, bites it, and then that fish will, the little babies will attach to the fish and then take a ride and gain some nutrients from that fish for a little while. But not all mussels want to attract the same fish because they live in different habitats. So this is the Wabash pigtail. One of its host fish is the creek chub. And you can see, I showed you earlier, that bloodworm midge. So on the bottom left is a bloodworm midge. Right above that is these little packets of glochidia called conglutinins. And those conglutinins are full of little babies. So the creek chub will go out looking, thinking it's going to get a meal, eat a bloodworm, but instead get this packet of glochidia, and those little mussels will attach to the fish. And so here you can see the glochidia on the left, and then you can see the glochidia attached to the gills, and then also on the fins of the fish. And so I got to thank Jim over at DuPage County Forest Preserve for all the pictures of the glochidia. And here's one more example. So the creeper mussel, it uses channel catfish as its host. And so it puts out these packets of conglutinins that look a lot like either a midge or maybe a black fly larva. And so you can see when you zoom in, you can see those little glochidia, and they've got those hooks. So they hook into the freshwater mussel, or they hook into the fish, and then that helps them with redistribution as well. So in the case of freshwater mussels, if you lose your fish host, you lose your ability to reproduce. And when you see the lure development and the conglutinins, you can kind of start to understand how long these individuals have been evolving together. So what we've learned is that the stream ecosystems are highly complex. The diversity within the streams is amazing. 22 species of native freshwater mussels, over 60 species of fish. I don't know how many macroinvertebrates, but we've got a lot of macroinvertebrates. And so if you look at any one of these groups of animals, it gives you a pretty good idea of stream health. But if we look at all three groups of animals, the overall picture of stream health becomes much clearer. And so how do we understand stream health? It really takes a community. So with community collected information, we can get baseline data for stream health using biological indicators. And from there, we can continue to monitor streams to ensure stream ecosystems are healthy. And so I've got a video, one more video. And this was in Indian Creek as well. But a lot of these species are in the Kishwaukee River shed as well. So first the horny head chub comes in and he builds the nest. So he moves a bunch of rocks, removes the silt, and then they breed over that. And then after they build the nest, all these other fish species come in and breed on that same nest. So the ones with the red underside, you have southern red-bellied dace. You'll see a couple species of shiner. One of them's common shiner, and then you'll see creek chubs in there as well. So it's really fascinating what's going on in those streams. And so what are some good ways to learn about stream health near you? It's look at what the IDNR has put out, get involved with programs like RiverWatch and look for Illinois Natural History Survey reports, and then gain an awareness. KREP is a great way to gain some more awareness. Using iNaturalist to document and learn about species is another way. So if you're looking to improve your stream health, you could talk to Soils and Water or NRCS, and thank your neighbors for doing good practices. If they've got buffers along their streams or grass waterways leading into those streams, then those all help. And so thanks everybody for coming out. And thank you all for helping future generations enjoy and protect our stream ecosystems. I'll go back to this video just for a second because we'll just end it with looking at some fish.
Well, thanks,